we're asked to find the derivative of y equals to s cubed using the first principle method. Let's start. Solution. Now here, y is equals to s cubed. Y here is the dependent variable, while x is independent because y depends on the value of x. So y equals to x cubed using first principle method. First step, y, change your y to be y plus delta y, or let's use let's use another symbol, which is change in y. Y plus change in y. This is equals to our x also will change. So that will become x plus change in x. So this has taken x. And s is raised to the power of 3. So we have s raised to the power of 3. That's the first step. Now, here we need to expand. From our binomial expansion, let's assume we are given s plus y raised to power 3. We know that s is decreasing down the value while y is increasing. And their coefficient, according to the Pascal triangle, we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So this is a power of 3. So therefore, that is going to become equal to the expansion of this now, that is s raised to the power of 3 plus 3x delta x, and take note that this is now s squared because s is decreasing, plus this is now 3s delta x all squared. All right, so plus the next one at the coefficient is 1 plus delta s all cube. That is it. This is the expansion. We are still on this, which is y plus change in y. The second step is for us to subtract y from our step 1. So here we have y plus change in y minus y, which is equals to s, everything here first, s cubed plus 3s squared change in x plus 3s change in s squared plus change in s cubed. That is y plus delta y. Minus y now is s cubed. So that is now s cubed. By cancellation law, we know that s cubed cross s cubed. So we are left with change in y, because y here also cross y here. So change in y is equals to 3x squared delta x plus 3x delta x all squared plus delta x cubed. Now, we can factorize delta x out. So if we factorize delta x out, we have delta x, which is change in x, equals to 3s squared, there's no more delta x here, plus 3s change in x plus change in x squared. Now here, we now divide delta y, change in y, over change in x. Why are we dividing by change in x? Because we are looking for the derivative of y with respect to x. So that is why we have x here. If this is y, if y equals to t cubed, then that will be change in y over change in t. So that's what we have here. So here also we now divide all three by change in s. Change in s cancel change in x. So here we are left with change in y over change in x equals to 3x squared plus 3x change in s plus change in s all squared. The last step is for us to take the limit. The limit of this as change in s tends to 0, which is what we are going to do here. We have limit as change in s tends to 0. Change in s tends to 0 of change in y over change in x. Now, when we take the limit of this as change in s tends to 0, we just substitute our value of delta s to be 0. So here we have 3x squared. Now, one of the property of limit is that when we have the limit of a constant, is still equals to that constant. So let's say limit as x tends to 0 of 3 is still the same thing as 3, because there's no way to substitute the value of theta s as it tends to 0 2 in this particular aspect. So that is why we have 3s squared for this one. And this now, we substitute this place to become 0. So that's 3s squared times 0, which is still 0. Here, 0 squared is 0. So we have 3s squared plus 0 plus 0. Now we take the limit of this as theta x change to 0. It becomes dy dx. So when we take the limit of change in y over change in x, it's equals to dy dx equals to 3s squared. And that is the derivative of s cubed. So if we are asked to find the derivative of s cubed, it is equals to 3s squared using first principle method. And even the standard derivative is still the same thing. But derivative of s cubed is...
Subscribe to my channel.